is today's homework. All right, and classwork homework. Be good for the sub today. Wednesday is a test, so remember Wednesday is a quiz on this stuff. So make sure I'm going to go over this and what we're learning today and tomorrow too. So remember Wednesday's the quiz. So when you're doing this, anytime there's parentheses, you're going to use distributive property, right? Always do what's inside the parentheses first. There's nothing you can do. But remember, this has an exponent of 1 right here. When you can't do anything in the parentheses, then you look at the outside of the parentheses when you can distribute power to a power. Okay, distribute power to a power. Distribute is just a fancy word for multiplication. So you got x4 times 2. And then this 4, base of -4, in parentheses, 1 times 2, this 1 times this 2. Okay, so your answer is -4 squared, which is -4 times -4, which is 16, and then x to the 8. Or if you on the test you leave it x to the 8 like that, that's okay too. But you need to know that these two means the same. Okay, there's no parentheses here. Let's do all the exponent first. Here's z. So normally we do alphabetical order. W comes first. So let's do the w to the 9th. And this is a w to the 1st, okay, invisible one. So this belongs right there. So plus, when you're multiplying exponents, when there's no parentheses, you're adding them. Okay, you add them. This is how you show the work. Remember this for your quiz. And then you do the z to the 4th plus -5. Okay, and then you do the multiplication without the exponent. Order of operation says multiplication next. Okay, multiplying next. -3 times 2, -3. I'll change the color in pink so you can see. -3 times the 2. So w to the 10th, z to the -1, and multiply last, -6. That's your answer for right now. You learn you can't have a negative exponent. That's not simplified. Now when you're done with everything you learned today, these are the next IXL you need to do. It's up on the board also. When you have to dividing, you need to remember with division, you have to subtract the exponent. Let's do the exponent first. X to the 1. This is x to the 8, x to the 1. Take out the smaller one. The division one is the only one you put the division sign, cross that out. That's a 1 times, right? And then -1, that's x to the 7th. And then you simplify 12 divided by 4. You divide both by 4. That's 3 times the 1. So your answer is 3 to the x to the 7th over 1, or just 3x to the 7th. This was Friday's homework. So these are the rules so far. Parentheses, you distribute. Without parentheses, you add the exponents. Okay, with the base are the same only. If they don't have any, like this, you just do your normal multiplication order of operation. Those 3 things will be on your quiz Wednesday. Find the value, make the statement true, show all work to support your answer. Okay, this is 6 to the n times 6 to the 1, and then to make 36 is 6 to the 2nd. Okay, you change this 36 to a base of 6, just like all of these has a base of 6. 6 times 6 is 36, okay? Then because these are all multiplication, you add the exponent, right? So n plus 1 equals to this 2. Minus 1, and then equals to the 1. This will be on your quiz on Wednesday also. It'll be more something like this, though, where the base is already the same. When the base are the same, it's multiplication. You add 4 plus this n, right? So 4 plus the n equals to this negative 3. Minus 4, n equals to negative 7. So the n here is negative 7. Okay, here's today's lesson. Learning about negative exponents. Simplify the fraction. Both can be divided by 4, 1 over 1, or just 1, right? Both can be divided by 9, 1 over 1, or just 1. Again, when it divides by itself, it's a 1. Okay, 25 divided by 25 is 1 whole. Write the quotient. What is the quotient of any number divided by any number divided by itself is 1. The quotient, the answer is 1. Rewrite each numerator and denominator from question 1 as a power. Do not simplify. Okay, write it as a power. A, write it as a power, 4 to the first, 4 to the first, right? Do not simplify. That's all they want you to do. 9 over 9 as a power, 9 to the first, 9 to the first. And then the last one is 25 to the first, 25 to the first. Okay, simplify each fraction from question 3 using the quotient of a power rule. Leave your answer as a power, okay? Let's simplify it as a quotient rule. 4 to the 1 over 4 to the 1. 9 to the first over 9 to the first. And then 25 to the first, 25 to the first. They want you to simplify using the quotient rule. The quotient rule is you subtract, cross out that 1, that becomes 1, right? You subtract that, 4 to the 0 power. And remember on your IXL, anything to the 0 power is 1. Leave your answer as a power, right? Or 4 to the 0 power, correct? You don't have to write that. You can eliminate that 1. So, cross that out. Leave denominator as 1 minus the 1. 9 to the 0 power, or just 9 to the 0 power without 1. Same thing here. Just cross that out. Okay, make it a 1 minus the 1. 25 to the 0 power, or 25 to the 0 pi, eliminating the 1. And here the question asks, write a rule you can use when raising any power base to the 0 power. Anything raised to the 0 power, anything raised to the 0 power is the answer of 1. Okay, anything raised to the 0 power. Remember on IXL, a lot of you asked. So use the quotient, simplify each one. Okay. If they are the same, always eliminate the denominator. Bring it to the numerator. 6 to the 0 power, which is 1. Eliminate the denominator. Make it a 1 minus that 9. 4 to the 0 power, the answer is 1. Okay, when you're dividing, you're subtracting the exponent. Okay, so here, for example, exploring powers that represent number less than 1. Simplify each expression using the quotient rule of power. Show your work. Okay. I would eliminate the smaller one, make that a 1. 0. So your answer is 10 to the 3rd power. That's what I would do. You do this? Well, or you can say anything to the 0 power is 1. 10 to the 0 power is 1 over 10 to the 5th. I really would like you to learn, take out the smaller of the exponent, make that numerator 1, minus the 0, 10 to the 4th power, like that. Same thing as 10 to the 0 power. 10 to the 0 power is always 1. Okay. And anything to the 0 power is 1. Okay, rewrite the power so that the exponent is positive. Okay. When you have something like this, and that's one of your IXL you need to do, anything with a negative exponent, it's not simplified. You have to simplify it. That means the denominator is 1, right? All of these has a denominator of 1. Okay. You take that, you switch it. This one becomes your numerator, and the other one becomes your denominator. And that negative here turn into a positive, and that's how you make it positive exponent. Okay? This really means 1 over 5, instead of this negative, make it a positive to the 6th power. So here, 1 a to the positive 5, right there, like that. So this is 2 problems. That's multiplication, right? A 1 and a 1. So 1 times this 1, you flip it to the top, numerator, 1 times 1, and b squared times c to the 3rd. These negatives becomes a positive. So 1 times 1 is 1 over b squared c cubed, like that. Okay, just switch it. All right, so that's very important, you know. This is saying the expression, this can be simplified using the product rule of power, quotient of power rule. An expression is not considered simplified. See, an expression is not considered simplified if it contains a negative exponent. So this is not simplified because of this negative exponent. So you add them. 5 plus a negative 7 is k to the negative 2. So that's not simplified. You need to put a 1 under, flip it, 1k to the 2nd power. Okay, so So here they did it like this, right? Same thing. If I had this problem though, to alleviate problem, I would eliminate that. I'm going to show work like this. Because we eliminate becomes a 1. This is a 5, right? So minus 5k to the squared. I have the same answer here. But if you take it to the top, what they're showing here is you can take this big number to the top, minus 7. And that would be a 1 on the bottom, right? And k to the negative 2. It's not simplified. K to the negative 2 is the same thing as this answer. You need to make it, flip it like that. That's what it's telling. You can move it either way. But if you move it to the smaller number, it's a negative answer because of additive inverse. And you need to move it like that. Okay, there's 2 ways to do it. That's what I'm trying to tell you. I'm going to keep it my way, which is this. This is division. I'm going to subtract the exponent. If it's multiplication, I'm going to add it, okay? First, to exponent. There's no exponent outside. I'm going to add it. So x to the second, add negative 3. I would get x to the negative 1. I cannot, that is not simplified. To simplify it, I put a 1, then I switch it, 1 over x instead of a negative 1, x to the 1, or just invisible x, like that. You can put a 1 if you like. Okay? So same here. This is a multiplication. This is a multiplication problem. I'm going to add the exponents. Okay? So 9 to the 4th plus a negative 5. So I get 9 to the negative 1. This is not simplified. So I put a 1, the same thing as a 1, flip it, 1 over 9. Instead of a negative 1, flipping it over makes it a positive 1. And this 1 can be invisible, becomes 1 over 9. Okay, let's look at the first one. This is division. Division, you subtract the exponents. So division, this means you cross 1 out, make that a 1, take it, subtract. Okay? So you got 2 to the 4th power. I need to see this work. I need to see this crossed out to show the work. All right? No answers only. You'll get a 0. I need to see the steps. I need to see the steps. All of it. So here, this is a division. So I'm going to subtract the exponent. They're the same, right? Cross out 1. I like to cross out the denominator. If they're the same, I always like to cross out denominator, and it's easier. 1. Okay, I'm going to add. Oh, we're subtracting. When you divide, subtract, right? This negative 3. Subtract this negative 3. Becomes plus plus. That's a 0. 3 to the 0 power. Anything to the 0 power is 1. 1 over 1, or just 1. Okay? Division means I subtract the exponent. So, when I see divide, I need to put that line in again. Okay? See divide, put in the line. all division. Put in the fraction bar you see here. Don't miss the fraction bar with division. It stays. Okay? You can leave your answer as 1 over 1. If you forget that, I'm fine. But you need, if it starts out with a fraction bar, the answer stays a fraction bar. Don't let it go. If it doesn't have a fraction bar, well, you sometimes end up with it if it's a negative exponent. Anyways, this point is this starts out with a fraction bar. Let's do the 2s, same exponents. Same exponents, right? So you get, cross that out, that gets a 1, minus the 2. So notice this goes at the bottom, because this is from the bottom. Okay, that's negative 2 squared. Okay, I'm going to do now green, this and this. Put times in between them before you start the other one. That's exponent of 1. Cross that out because it's smaller than this one. Minus this 1. So y to the 6th power. Oh, and this one gets a 1. So we cross this out. Let's get a 1. Put that minus 1 here. You get the 6. Okay, 1 times 1 is 1 over negative 2 squared, or 4. If you put negative 2 times negative 2 is 4, that would be correct too. Y to the 6th power. If you leave it like that, I'll be extremely happy. Okay. So, this is times. Start out like this. Times, 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 times. Okay. Let's take the exponent first, or we can simplify. Divide both by 5. 5 into 5 is 1. 5 into 20 is 4. The base are different. This is base same. 1. That's smaller than the 4. Cross that out. Becomes a 1. Minus the 1 here. N to the 3rd. 1 times 1 is 1. 4 times n to the 3rd is 4 n to the 3rd. And that's your answer. Okay, here, do not simplify this. Remember, only reduce, simplify if they are different like this. If the base are the same, like number 7, you just subtract the exponent. That's times, times. Let's put those down. Start with the 6 first. Which one gets a 1? The 6. That's a 1. Minus the 4. So 6 to the 1st power. Because of 5 minus 4 is this 1. Okay, the second one, you take this right here. Okay, this is the smaller of the 2. That becomes a 1. Take that, you need to write that down. Once you cross it out, you need to put minus this and a 1 for in the spot that you cross out. 10 minus 8 is 2. This answer, this is at the bottom. The answer is at the bottom. It's 2. 6 to the 1st times 1 is 6 to the 1st, or just 6 without this is invisible. 1 times m squared is 1m squared. If you want to put a 1, you can. Oops. It's 1m squared. And you can make the 1 all invisible, and that's the same answer, okay? Okay, here's a multiplication. Times, times. These are different. You have to reduce them. That means you divide both of them by 2. 1 over 4 Bring down the multiplication, times, times. These have the same exponent. Cross out one of them, make that a 1. Minus 6, h to the 0 power. Well, h to the 0 power is 1. So h to the 0 power is 1. This is 1. 1 times 1. 1 times 1 over 4. 1 times 4, so it's 1 over 4. Okay? If this is multiplication, you add the exponent. Got to know this. Only add the exponent with the same base. Look to the exponent first. P to the second plus a negative 7. And these are different. This 5 times this 2. There's no exponent. We multiply and we get 10. P to the negative 5. You cannot have a negative number that is not exponent, not negative number. You cannot have a negative exponent. It's not simplified. So put a 1, flip it. So 10 over p to the 5th power. Put this at the bottom, 1. So 10p to the 5th power. That's your answer. Here, notice you got times, but the exponents, these have the same base. You can do order of operation and do 4 times. No, you can't do 4 times. You need to do this one first. 4 times 4, first, 4 squared, then get that answer, which is 16. Then times the 4. You can put 64 if you like, but you cannot multiply these together. Okay. Times k to the negative 4, and this is a 1 plus the 1. You can't multiply k, so you have to add the exponent. So k to the negative 3. This gets a 1. So your answer is 64 times 1 over k to the 3rd. So you get 64 over k to the 3rd. Okay? Okay, let's review this. Now you guys get confused with all the rules. Just rules that you've learned. This is multiplication. There's no to inside first, nothing to do inside. There's no exponent outside, so we don't distribute. So we can add stuff with the same base. Okay, this is 3 squared times 3 to the 4th power. They're the same. You cannot multiply 3 times 3. If you want to multiply, you need to do this first. That's 81 times 9. That's a big number. Or you can just say it's the same base. You can add the exponent. So 3 to the 6th power. Like that. Okay? Or another way. And then you can do the x squared, x to the 5th. So you get x squared plus 5, right? So x to the 7th. And then y, you look at the y to the 4th. And then y to the 1st. Y to the, let's show work here. Y to the 4th plus the 1. Y to the 5th. And that's your answer. Okay? This is multiplication. These are all times. So 5 to the times the 5. which is 25, or 5 squared if you want to put, because it's 5 to the first and 5 to the first, m to the first and m to the fourth. Let's do that one. M to the first and m to the fourth. Okay, you got m to the 1 plus the 4. M to the 5th. And then you get n to the 7th and n to the 4th. So n to the 7th plus the 4, you get n to the 11th. That's your answer. And letter C. Oh, always order of operation inside the parentheses. You can change this to 25 or go and I'll leave it alone. And notice that this is on the outside, so you distribute. That's a 1. It's a 1 also, so m to the 3rd. Distribute. M to the 3rd. Distribute. 5 to the 6th. Distribute is a fancy word for multiplication. And that's your answer. Show the work by putting this. If I don't see it, you'll get a 0 tomorrow because you're just copying this answer without any work or trying to understand. This is all review. You've learned this. Exponent of 1 here. This means parentheses mean to distribute. That's f to the 40. Distribute is fancy word for multiplication. 4 to the 4th power. And that's our answer. Okay? Okay, solve the following equation. This is review. You guys know how to do this. With additive inverse, add the ones that are alike first on the same side. That's 11n plus a negative 5. And that equals to this negative 16. Add the 5, add the 5. 11n equals to negative 11, divide by 11. N equals to negative 1. One solution, right? This is called one solution. Okay, this one here. Additive inverse first, right? Plus a negative. Combine the terms, a negative 17 plus 8. Copy the 6 plus, that's a negative 9x. Negative 9x on this side. Add this side, make it 0 on where the plus side is. That's 0, 0 plus the 6 is 6. And 9x, subtract 9x is 0. It's not equal to each other. No solution. Okay, here. Anytime you have percent problems, you automatically turn, first thing you do before you even read it, turn into a decimal. Oh, be careful here. This is not 0.5. This is 0.05. This is 5%, not 50. Okay, this is 50.05. So you have to put that in front like that. All of these have two numbers. You need to have two numbers after the decimal. Okay. Now, a student will eat 3,000 calories a day. The chart below shows the food and the calories a student will eat. The table provides the percentage a person each food type. A person eats each day. Redundant. All right. So, Student will eat 3,000 calories. So you multiply this by 3,000 calories. 30% is from fries. 65% is from cheeseburger. Oh, times 3,000 a day times 3,000 a day. And one bottle of Gatorade, that's 150 calories each. Okay, you get 900 here. I'll use a calculator for the other one. 3,000 times 0.65, enter, 1950, clear it. Let's do this last one, 0.05 times 300, 15, 0.05 times 3,000, oops, 150 calories from Gatorade, okay? All right. Small fries is 225 calories. A cheeseburger is 650 calories. And one bottle of Gatorade, oops, I got this. It's 150 calories. Oh no. Divided by 150. So you're allowed one bottle of Gatorade a day. How many is this? 4 small fries. And how many cheeseburgers? 3? Check. Make sure. 1950 divided by 650. 3. Yep. 3 cheeseburger a day. How much of each type of food does this student eat each day? Okay. The student eat 4 small fries. 4 fries. The student eat 4 fries, small. 3 cheeseburger. And 1 bottle of Gatorade. Okay, let's explain how to do problem number 5. Start out with explaining. First, find the area of the rectangle by multiplying base, which is 24, times height, which is 12, to get, okay, 24 times 12, 288. 288 inches squared. Next, find, okay, we did this one already, so now we're going to do half a circle. So first we did area, base times height, area, 12 times 24. area is 288, okay, for the rectangle. Next, find the area of next find the area of half a circle. Pi times radius squared, where r is diameter. Diameter is 24, so radius is 12. Or 3.14 times 12 squared divided by 2. Divide by 2 because of half. Half to get. Okay, uh-oh, someone's at the door. 3.14 times 12 squared divided by 2. Area half a circle. Okay, let's see. We always do exponent first. 12 times 12 times 3.14 equals, I'm going to write this down because this little calculator of mine can't do more than, and then I have to divide that by 2. Just in case I hit something wrong. Divided by 2 equals, oops, so the area is to get 226.08. 226.08 inches squared. Lastly, add 22.208 plus 288 inches squared for the area of the shaded region is 226.08, 08.1411, 514.08 inches squared. That's how we do this. Oops, sorry. Here. That's what I wrote. Write smaller than I did so it all fit in. If not, use the back of this paper. Hopefully this helps you.